Good day, everyone, and once again we are back together. Your favorite uncle once again with you. And today we are going to be looking at histograms. We're going to be looking at bar graphs, okay, in relation to statistics. So if you haven't subscribed as yet, please just make sure that you are part of the family. Just hit that subscribe button. And of course, at the end of the lesson, you're more than welcome to like and share, and also just give a good comment. I try by all means to, always respond to your comments. And wherever there are questions or when you need clarity, of course, you can always drop us an email. All right, all our details will be available on the description of this video. And of course, you can visit our website for all our value-added services. And our address rather is www.mlungisi.co.za. All right, and of course, at the end of the lesson, you can also just give what we call super thanks. Okay, this is a monetary gift that you can just give just to acknowledge or to show appreciation. All right, let's get into our lesson without any further ado. All right, so let's talk about bar graphs. Okay, so essentially, let's just make an example. Suppose that we were measuring, let's say, the revenue or the amount of money that a company makes on a weekly basis or on a monthly basis, for argument's sake, right? So we can interpret that information in terms of a bar graph. Okay, let's say for argument's sake, we would have on month 1. Okay, so let's say this is the amount of money that that company would make on month 2, and let's say on month 3. Okay, that's the amount of money. All right, so let's say this month was January. Of course, we know that you don't make as much money in January because, most people don't have money, right? And this would be February. So this is what we call a bar graph, right? So this is a bar graph. Okay, so all that you can do from a bar graph is just to take, obviously, the amount of information. Say, for argument's sake, we were able to make 10,000 rands, and then, on this one, let's say 18,000, just making an example with that. And then on this month, we're able to make 6,000 rands. Okay, so this would be month 1, month 2, and month 3. So in a bar graph, you'd always have the information, but you'd have spaces in between, right? So what you can do is just take the information that is given, obviously the amounts there, and of course we can calculate the mean, we can calculate the variance, and so on. We've already covered that, right? Now the difference between a bar graph and what we call a histogram, right? Now in a histogram, you see now I'm even writing it incorrectly. Now in a histogram, what you have there is that you are actually, it's a diagram that gives us statistical data, right? Now, just like you would have, when you've got a cumulative frequency curve or an ogive or ogive, right? In this case, let's say for argument's sake, we are just giving information on the amount of marks that learners obtain. So 20, 30, 40, 50, and so on and so forth, right? So in a histogram, what you'd realize is that, let's say, this is the amount of marks that, the learners that got between 10 and 20%, let's say for a test, let's give a very small number. Let's say it's just 3 learners, and then let's say the learners that got between 20 and 30, just a slightly higher. Okay, let's say that would be 5 learners. Between 20 and 40, that would be 10 learners. Okay, and so on and so forth, right? Let's say this would be 8 learners over here. Okay, now this is what we call a histogram. And what does it give you, right? It would give you obviously the the upper bounds and the lower bounds of your intervals there. So you've got an interval between 10 and 20. Okay, so interval between 10 and 20, I've got 3. And then I've got 5 between 20 and 30. I've got 10 between 30 and 40. And I've got 8 between 40 and 50. Now, what we can do, now please, I want you to note this very carefully. So in this case, there are two things that we can, draw from a histogram. First of all, they could ask us to draw a cumulative frequency on Ogive, okay, based on the data that you have. And how do we do that? Of course, in this case, I'm going to try and make it as simplified as possible. So we're going to have 10, 20, 30, 40. Okay, so there we have it there. That's 20, that's 30, that's 40, and that's 50. Right? Now notice in this case, what are we going to do? Remember, we always take the upper bounds of the values, right? So it means at 20, right, between 10 and 20, we take the upper bound, which is 20, all right? So we obviously, our value will be 3, right? So it means at 20, our value will be 3 there. And then you've got now at 30, in this case, what would be your value? Remember, for your Ogive, it's a cumulative frequency. So in this case, you'll say 3 plus 5. So that would be 8. So it means that at 30, you'd have 8. Okay. And then your between 30 and 40, remember, we take that upper bound there. So meaning at 40 now, we'll say 3 plus 5 plus 10. In this case, that would be 18. So it means that this value would be 18 there. So that is how we draw our Ogive, isn't it? Okay, and of course, for the last one at 50, we'd say, okay, that 18 plus 8, in this case, that would give us 26, right? So in this case, what we would do there is that we know that at 50, our value is 26. So remember, in this case, we always need to start at the lower boundary. In this case, so your lower boundary would be at 0. So this would be your Ogive. And of course, you can always interpret what you need to interpret, as we did in the previous video. So keep in mind, in this case, this is our cumulative frequency, when it comes to the histogram. But another thing that we can also have on the histogram is that we are also able to draw in this case a frequency polygon. Okay, so frequency polygon, what you do is that you take the midpoint of the values, right? So you take the midpoints of the values, right? And at the midpoint of the value, we are just going to connect those dots there if they ask us to draw the frequency polygon. But remember, you need to anchor it at 0. So it means in this case, you're just going to pull it like that. Okay, right. So that would be your frequency polygon. All right. So in this case, what I want us to quickly do is just to take some examples on bar graphs as well as histograms and see how to interpret that in statistics. All right, now let's have a look at our first example. So they say to us the number of aircraft landing at King Shaka International Airport and Port Elizabeth Airport, okay, obviously now called Gqeberha, okay, for the period of starting in April 2017 and ending in March 2018 is shown in the double bar graph below. Right, now please note, in this case, you are given a bar graph, right? So what we want to do in this bar graph, obviously what we're going to do is just take information from it, right? They've given you information from April just up until March the next year, right? Now, what they ask us there is the number of aircraft landing in the Port Elizabeth Airport exceeds the number of aircraft landing in King Shaka International Airport during some months of the given period. They say, during which month is the difference the greatest? Ladies and gents, I just want you to note, when it comes to the bar graph, all that is left for us to do is just simply to interpret the graph, right? And I want you to note in this case, I can see clearly that on the month of July, that's when you've got the greatest difference. So in this case, I'm just simply going to answer that and say July. That's when you've got the biggest difference between the landings, right? Right, the next question, they say to us, the number of aircraft landing in at the King Shaka International Airport during these months as follows. So they give you the number there. Obviously, they would have sourced this data from our bar graph. In this case, we don't have accurate numbers, so they've given us that data more accurately. Right, so in this case, they say to you, calculate the mean of the data. Now, ladies and gents, you'll allow me, what I've already done is I've kind of put in that data there on my calculator so that it wouldn't take time. Of course, in your case, if you're using a calculator, you would say shift. In fact, first of all, you go to mode, you choose stat mode, right? And then obviously you are going to choose the one variable there, right? And then thereafter, of course, you're going to put in the data. Please remember to press AC to store it. And then you say shift and you say stat. And that's exactly what I'm going to do here now, right? Shift and then I go to stat, okay? And I say one variable calculation. So there it gives me my, in my case, right? It gives me my my mean, but it also gives me my variance there. I see I've got a mean of, okay, let me just try to write it down. Okay, so I've got a mean value of 22 for 5.03, okay? And in this case, my standard deviation value, of course, in your case, you're going to say shift stat, and then you'll choose standard deviation, and you'll choose mean. My standard deviation, okay, is 86.3, okay? So that's my mean, and that is my standard deviation. All right, so that would be my answer for this one. Okay, they said calculate the mean, so we know that x bar in this case would simply be equal to 2245.08. Please verify that you get that number. And then, of course, for your standard deviation, in this case, you get 86.3, right? Now, they say to you, determine the number of months, okay, in which the number of aircraft landing in King Shaka International Airport were within one standard deviation of the mean. So remember, when we say a number is within one standard deviation of the mean, okay, let me just number my work there. So remember, this was 2.3 and this would be 2.4. No, actually, this was 2.2 rather, and the other one is 2.3. Okay, so that's 2.2, 2.3. Right, so 2.4, what they ask me is to find out the numbers that are within one standard deviation. So we're going to say, remember, when we say within one standard deviation, we're going to say x minus the standard deviation, or rather the mean minus the standard deviation, and x plus the standard deviation, in this case the mean plus the standard deviation. Right, when I calculate it there, I get a value of 2158.78 and 2331.38. Okay, right. So what should I do? I must look for values that are between these boundaries, right? Remember, they said within one standard deviation. So let's see, 2182, is it between 2158 and, yeah, definitely this one is, okay, 2331 2, 3, I think that's also within, definitely. Okay, this one is definitely within as well, 2, 2. Okay, and 2, 3, 3, 4, no, this is not. 2, 3, 4, 6, this is not. 2, 1, 7, 5, okay, this is greater than 2, 1, 5, 8, so this is. Okay, 2, 2, 9, okay, this is definitely within. 2, 2, 6, 3, definitely within. 2, 2, 1, 5, definitely within. 2, 2, 7, 1, definitely within. Okay, and 2, 0, 1, 8, nope, it is not. And then 2, 2, 5, 4, definitely within. All right, so I see it's actually 9 months in which we are within one standard deviation. So in that case, that would be 9 months. Okay, right, hope that makes sense to you. Right, and then finally, they say to us, which one of the following statements is correct? They say during December and January, there are more landings at the Port Elizabeth airport than at King Shaka. Let's go back to our graph and see if that is the case. Okay, so December and January, nope, that is not true. Definitely there are more landings on King Shaka in that case. And then the second one, they say there was a greater variation in the number of aircraft landing at King Shaka Airport, okay, than at Port Elizabeth. In this case, for the given period, no, I would say there was a greater variation at Port Elizabeth than at King Shaka, so that wouldn't be true. And then finally, they say the standard deviation of the number of landings at Port Elizabeth will be higher than the standard deviation for the number of landings at King Shaka. I would tend to say that is true, because think about it, that value there is quite high compared. You've got an extremely high value and another extreme low, whereas if you look at King Shaka, it's more or less, more or less the same number in a sense. So definitely the standard deviation would be much higher for Port Elizabeth than for King Shaka. So I would choose this answer here. I hope you understood that, ladies and gents. Let's take our second example that has to do with histograms. All right, now we have a look at, an application of a histogram. Right, so they say the marks obtained by learners of a certain school in a mathematics test is represented in the histogram below. All right, so there's the histogram that is given to us there. Right, let's just try to zoom into it. Now, we're going to answer the questions, but remember, if you were asked for argument's sake to draw a frequency polygon, remember what you would have to do is just get the midpoints there. Okay, and upon obtaining those midpoints, all you simply do is that you just join the midpoints there as much as you possibly can. Okay, of course you're going to try and draw more straighter lines than I am. Okay, and obviously the last one would be this one over there. Okay, and essentially that is how you draw the frequency polygon, right? But in this case, that's not what we're asked. Okay. Oh, by the way, when you draw the frequency polygon, please remember that you must anchor it at 0, at the first point. So in this case, I would put a 0 there in the first midpoint. Okay. So you'd actually anchor it at the x-axis like that. Okay. Right. Now let's answer the questions that were actually asked. Right, now they say to us, how many learners wrote the test? Now remember, what I'm simply going to do is, how do we interpret this histogram? What it simply means is that learners that obtained between 20 and 29%, there's only 2 learners in that case. Okay, and then learners that obtained between 30 and 39 are 8. So what are we going to do? We're just simply going to calculate the number of learners in total here. All right, so that's 2 plus 8 plus 12 plus 32 plus 46 and all of those numbers, and I got a total number of 140 learners. Okay, so it's 140 learners that wrote the test. Now, they say write down the modal class, so it means that where we had the most number of learners, so that is 46. In this case, what is the modal class? So that's between 60 and 69. So our modal class, x is less than 70, greater or equal to 60. Okay, so that's our modal class of the data. Right, now they say draw the ogive for the given information. Now remember, cumulative frequency, what are we going to do? So I draw I drew a little table there, okay, that we're going to use to kind of populate the data. Right, so our first value, obviously between 20 and 30, we've got 2 learners, right? And then between 30 and 40, in this case now, I'll say 2 plus 8, which is going to be 10. So our next value is 10. Of course, the next one, that would be 2 plus 8 plus 12. So that would be 22. Okay, and then obviously you'll keep doing that. You'll just keep accumulating the learners. So the number is 54. I've got 100 there. I've got 122. I've got 138, and I've got 140. Right? So that is going to be our values. Now remember, we said we always take the upper boundaries, isn't it? Okay, so we always take, in this case, the upper bound values, okay, for our cumulative frequency or for our ogive, for our ogive, for our ogive, whatever you want to call it, okay? So in this case, I'm going to try and draw that in as simplified a manner as possible. All right, so in this case, at 30, my value is 2 there. So I can see that my divisions in this case are in terms of 2. So at 30, I've got 2. Okay, let's try and do that there. So I've got 2 there. And at 40, I've got 10. All right, so there's my ogive. At 50, I've got 22. There's 22 there. At 60, I've got 54. All right, so it's getting more intense. So that's 54 over there. At 70, I've got 100. So at 70, I've got 100. So there's 100 over there. And at 80, I've got 122. So at 80, I have got 122. That's my 122 value. At 90, I've got 138. Okay, so that's 138. It's that value there. And of course, at 100, I've got 140. All right, I know that we can't really see that value very well. Okay, but nonetheless, all right, so remember, in this case, my lower boundary, I'm going to make the x-intercept. So in this case, I'm going to make this 0. Of course, you try and draw a smooth curve. All right, so that is my ogive. All right, so that's what my ogive would look like. Okay, right, now they're probably going to ask us something related to the ogive. They say use the ogive, in this case, to estimate the interquartile range. Now remember, the interquartile range would always be Q3 minus Q1, okay? So how do we get Q3? In this case, remember that Q3 would be 75% of your data, and Q1 would be at 25%. Okay, now I'd say what is 75% of 140? Okay, minus 25% of 140, right? So let's do that. 0.75 times 140. I'm getting 105. Okay, so we're gonna go to our Ogive and find the corresponding value at 105, and then we're also going to find okay, at 25%, that's 35. Okay, so we go to our data, and then we are going to find, now please, I want you to note, we're going to find 35 and 105. Okay, so meaning 35, where is 35? Okay, I might have to take my ruler here just to make things a little bit easier for myself. Okay, so I'm going to take 35. All right, it's somewhere in the middle there, right? Okay, yeah, right there. Okay, so at 35, what is my corresponding x value? That would be my Q1. Okay, so that's 35 there. All right, so what is my corresponding y value? So let's make sure our ruler is at 90 degrees. Right, there we go. So that's the corresponding x value, and the marks obtained there. I know it's not fairly as accurate as it should be. Okay, and the other value is at 105. Then we go to 105. Okay, and then we're going to find Q3. So that's 102, 104. So 105 is over there. All right, so let's find 105. And then what we'll do is we are going to find our interquartile range. Okay, this looks a little bit tedious because I'm using technology here and it's not really responding as it should. Of course, I'm going to give an estimation. Obviously, yours might be a little bit more accurate if you do it. Right, so that is my Q1 as well as my Q3, right? So now that means that this is my Q1 value and this is my Q3 value. All right, so let's calculate there. So Q1 would be around, shall we say, in fact, I think it's not exactly at 56. Let's say 55. Okay, let's say 55 because I made it touch the line. So Q1 is at 55. Okay, and then Q3 is at 70, shall we say 72? All right, so my interquartile range in that case would essentially be 72 minus, we said 55 for the other one. So in this case, 72 minus 55, that would give us 17. Okay, right, sorry about that. Okay, so that would give us 17 for a final answer. All right, hopefully you were able to understand that. Okay, so that is how you would essentially find Q1 and Q3. That is the amount of marks for your interquartile range. All right, hopefully, ladies and gents, that was easy enough. That's it when it comes to histograms. That is how you'd interpret your information. All right, ladies and gents, we've come to the end of our lesson. And by the way, just a quick reminder that you've got a super thanks feature right at the bottom there. You can use it, obviously to try and bless your favorite uncle, a monetary gift of any amount. And by the way, you can also go to our, on the channel, remember to always use playlists, right? Our playlist feature will actually give you all the lessons that you need in playlist format. so that you'd know how to follow on to our lesson. And of course, please just get us to that 100,000. We're trying by all means to get to that epic number of 100,000. Please subscribe. Please tell all others, to subscribe onto your favorite uncle's channel. And of course, finally, you can also go to our website, www.mlungisinkosi.co.za, and you can get there, past exam question papers by clicking on there. But if you also want to have other courses and services that are available, and of course, you can always contact us there. Ladies and gents, I think that is it for today. All right, so hopefully you were able to enjoy that lesson, and I'll see you guys again next time. We will be discussing fundamental counting principles as our next section. Otherwise, from me to you, for now, sharp, sharp.